Welcome back to the part 3 of past paper walkthrough of the 2021 chemistry higher paper. So without further ado, let's get started. So question 7 is about electrochemistry. Electrolysis and chemical cells both involve chemical reactions and electricity. Explain the difference between the process in electrolysis and in a chemical cell. So electrolysis is a purification method in which electricity is used to carry out redox reactions, and you're trying to do a reaction using electricity. So let's see, we should write electrolysis use electricity to run reactions, whereas for chemical cell, not chemical gel, chemical cell, if I can write properly. For chemical cell, electricity is generated. So it's generated by reactions. So that's the main difference between those two, is essentially one is the other, the counterpart of the other, but it's slightly more complicated than that in reality. So there you go. A teacher demonstrated electrolysis of molten lead bromide. That's very brave of that teacher. So you're making bromine on the positive electrode, which means that the positive electrode always draw electrons out of compounds. So bromide anion is going to become an electron and bromine 0. And because this is a half cell equation, we know that bromine as bromine 0 has to be a bromine 2, because that's just halogen or halogen, if I can speak properly. So halogen reactions are always in pairs. So you have chlorine 2, you have bromine 2, you've got iodine 2. So bromine 2, now that on the right hand side with 2 bromines, we need 2 bromides to counteract. So we need to put a 2 before the bromide. And now that we have 2 bromide to oxidize, you need to essentially make sure that your charge is balanced between the two. So on the left hand side you have 2 negatives. On the right hand side you must also add up to 2 negatives, which is 2 electrons. So that's your half cell equation. So for question 7.3, you have to complete this table of electrolysis, and you have 2 salts, and note they're in aqueous phase, which means that water is present. So this question is ridiculously harsh because they assume you have remembered the whole redox table, which you shouldn't have, because that's not really, I just don't think that's very fair. But anyway, I'm not the exam board, so I don't decide what you have to do. But for nitrate anions, they have a they have a higher potential than water, which means that water is preferentially oxidized in the positive electrode, which means that you're actually making oxygen gas on the positive electrode. It's like how when you electrolyze sodium chloride, you're gonna make hydrogen gas rather than sodium metal. And in fact, sodium chloride is very similar to potassium iodide, it's just a different ion. And potassium, again, is too reactive compared to water, so actually hydrogen gas is evolved at the negative electrode, and iodide becomes iodine. So iodine is I2. So that's that. So the next question is a very big one. I need to read this first. So the student investigate how the mass of copper produced at the negative electrode is varied using time and current. And the method is weigh the negative electrode, set up the apparatus, set a constant current of 0.3 amp, and after 5 minutes wash the electrode and reweigh, and then repeat step 1 to 6 for different times, and then do the same for different currents. Okay, that sounds like a decent method, I suppose. Some of the copper produced did not stick to the negative electrode but fell to the bottom of the beaker, so that's unfortunate. How could the student find the total mass of copper? So at this point, you're trying to weigh some copper solid in a solution of copper sulfate. Is this copper sulfate? Nitrate, copper nitrate. So this is essentially just a separation exercise, right? So what you want to do is to filter the solution, get solid, and once you have the solid must be dry, and you can dry that with vacuum, you can dry it with a desiccator, and there are a lot of ways to dry aqueous substance. Before you dry it, it's very important that you wash with distilled water. Because distilled water can rinse off all the excess copper nitrate, so that the copper nitrate doesn't form a surface layer on your actual solid copper. Right, and then once the copper solid is dried, you can go weigh it. And then you just add the number to total from the electrode mass. So that's how you mitigate that issue. And now we have a graph. So how does the result in figure 5 support conclusion of the mass is directly proportional to time? So when you are saying directly proportional in terms of graph, you're looking at a straight line graph from the origin. So that's essentially it. It's just a definition of directly proportional. This is actually a math question. If I can spell origin correctly. So yeah, that's just the answer, because these lines are all straight line through origin, therefore it is directly proportional. That's just the definition. How does the result in figure 5 support the conclusion that the total mass of copper is produced is directly proportional to the current? So this one is harder to look at, but there's a way. The current, when doubled, so if you double the current, the absolute amount of copper, which started as this one was, if I can read, 0.18, at 0.6, that's right here, which ends up to be 0.36, and at 0.9 this one is at 0.54, and you can see when you double your current, you double your mass. When you triple your current, you triple your mass. So that's the direct proportional relationship that you're looking for. So when and that's fine, that's the answer. So copper nitrate solution is blue, and the blue color fades during electrolysis, so you need to explain that. Copper nitrate in solution is blue, and because you're using up your copper nitrate as you're electrolyzing, the intensity of the blue should decrease to a point where it just stops being blue. So just say that copper nitrate is consumed during electrolysis, and therefore concentration of copper nitrate decreases. Okay, determine the number of atoms of copper produced when copper nitrate is electrolyzed for 20 minutes at 0.6 amps. Give your answer to 3SF, right? Okay, so 20 minutes at 0.6 amp, go back to the graph, is 20 minutes, 0.6 is this spot right here, and that is 0.22, oh no, 0.24 rather, if I can read, 0.24, and that was grams. And we want to find the number of atoms. Oh god, that's a big number. So first you want to find the number of moles, because we work in moles. 0.24 divided by the AR, atomic mass, which is 63.5. And I need to grab my calculator once again. Let's see, 0.24 divided by 63.5 gives me 3.7795 times 10 to the minus 3 moles. And the number of atoms is Avogadro's number times mole, which is 3.7795 times 6.02 times 10 to the 23. 10 to the 23 gives me equals to 2.27527 or well 75, so 8 times 10 to the 21, and we want three significant figures, which is 2.28 times 10 to 21. So that's our answer here. Question 8. This question is about the reaction between H2S and oxygen. So what does H2O gas represent? Steam or water vapor or whatever you want to call it. I normally just use steam because these are high temperature reactions. Calculate the volume of oxygen required to react with 50 centimeter cube of hydrogen sulfide. Right, okay, so according to ideal gas laws, the volume of gas is directly proportional to the mole. And we know that hydrogen sulfide to oxygen ratio is 2 to 3, which means that we want to find 2 to 3 ratio of 50. So 2 to 3 of 50 is 50 divided by 2 times 3. Why? It's just math. I'm not going to go into how to calculate ratios. If you want to check how to do ratios, go check out the math videos that I have on my channel. Admittedly, they're very old and I need to revamp them, but I'm not doing it here. This is a past paper walkthrough, not a math video. Right, figure 6 show a reaction profile. So you need to complete this profile, and we know it is an exothermic. So exothermic reaction means the energy is released into the atmosphere or environment, which means that the actual energy goes down compared to the start. And we need to complete the curve, and then we need to have the activation energy, which is from the top of the transition state to the starting energy. So this is EA, and the overall energy change, which is delta H, is this. So that's the completed answer. And you should probably also write down the actual components, which is 2H2O, 2SO2. Oops, that's an 8, not an S. I think that's about it here. Figure 7 showed display formula. I don't like display formulas. That's exactly the same reaction. Why would they do this? Oh, right, okay. I guess I see why. So what you need to do here is to calculate the bond energy for SO double bond, which is essentially you need to add numbers up, right? So we know the reaction profile, which is from a higher energy state to a lower energy state. And in the reaction, the energy released forming new bonds is that amount greater than the energy needed to break existing bonds, which means that it is exothermic by 1034 kilojoules. So this is 1034 apart, and we'll use that in our calculations later. So what we need is to tally up the total bond energy on the left side and the right side. So on left hand side, LHS, we have 2 lots of 1 and 2 SH bonds, which is 364. So that 2 364s on the left, and there are 2 molecules of H2S. So that's why it's 2 times 2 lots of 364. Add 3 units of oxygen double bonds, which is conveniently just one number. That's on the left. On the right hand side, we have 2 lots of H2O, so same logic, 2 lots of 2 single OH bonds, which is 464. Add 2 lots of 2 sets of SO2s, which is 2 lots of 2 SO double bonds, which is 2x. So 2 times 2 times x. And now if we add them up, we get, again, use your calculator, because I'm not doing mental math. Oh, this level of mental math is a bit too much for me. I'm getting a bit old. 2950, and that would be 2 times 2 times 464. Add 4x, 1856 plus 4x, and we know that these are energy to form bonds, or energy, no, actually these are, if these are negative numbers, these are the energy released from forming the bond, which is fairly confusing, to be honest. But well, we know that the right hand side should be lower in energy to the left hand side by 1034. So we have 2950 equals to the right hand side, and we need an extra, oh wait, hang on, the extra 1034 actually is on the left hand side, because how do I explain this? To go to 0 energy, right? 0 energy is elemental form. So all the bonds as it is doesn't as single individual elements, so oxygen atom, hydrogen atom, sulfur atoms, those are defined as zero energy. So to form a bond, it releases energy. So to form an O2, for example, that's minus 498 kilojoule per mole. And for this particular case, we have gone from 0. On the left hand side, we need to go down by 2950 to reach left hand side, and we need to go down 1856 plus 4x to the RHS right hand side. Yeah, and the difference between these two, left hand side and right hand side, is 1034 kilojoules per mole, which means that if we compare lengths in absolute units, it's actually 2950 plus 1034 equals to 1856 plus 4x, which is kind of counterintuitive, but that's just because the definition of elements are 0. So if you remember this, you draw these arrow down, you will not make mistakes. Well, you're less likely to make mistakes, rather. And now this is just simple algebra, and again, utilize your calculator. I tend to say abuse your calculator, but don't break it, because you do need it. So yeah, 3984 1856 plus 4x, which means that 4x is 2128, and then x is just that divided by 4 is 532 kilojoules per mole. Right. So big take-home point is make sure you understand how to define your 0 and work your way from 0, rather than think in the relative terms between the two sides, because that's just gonna confuse you. Okay, question 9. This question is about acids. HCl and ethanoic acid are both soluble in water, and one is a fully ionized acid and one is a weak acid, right? So a solution is made by dissolving 1 gram of HCl in 1 liter of water, and this 1 gram of HCl in 1 liter of water is a weak, a very dilute solution. So it's neither this or that. And HCl is a strong acid because it fully ionized. That's the definition of strong acid. So this is a dilute strong acid. Oops. Which solution have the lowest pH? So a low pH implies a high concentration of free-flowing protons or hydrogen ions. So 0.1 is a low concentration. 0.1 is a low concentration. Hydrochloric acid has a lower pH than ethanoic acid of the same concentration, so it's not the top one. If I have a higher acid concentration, or higher absolute concentration, odds are the higher concentration is going to be more acidic, more protons floating about. In which case it's going to be a lower pH. So actually, what we really need to compare is these two, 1 mole per decimeter cube. So actually, this probably isn't the right one either. And now between these two, ethanoic acid versus HCl, it's not ethanoic acid, so we know it's the last one. The student investigated the concentration of sodium hydroxide by titration with ethane dioic acid. Oh wait, this is a bit harsh. But anyway, measure the sodium hydroxide using a pipette, that's fine. Add 2 drops of indicator, that's fine. Fill the burette with the known concentration of acid to the 0 mark, that's correct. Add the solution until it changed color, that's fine and correct. Read the burette, find the volume, that's also correct. So nothing major red flag here. Suggest 2 improvement to increase the accuracy. So I suppose you need to make sure the solutions are well mixed, so you need to agitate the solution or stir the solution. It's very trivial. This you can also do concordant results. So you need to run the titration 2 times or 3 times until you get until you get 2 readings to be within I believe it's 0.1 of a mil apart, or it depends on your accuracy, you can go to 0.05 apart, and that will still be pretty fine. There will always be some error though, so concordant only means it's close enough. It's not absolutely exactly the same, because you always have error, but things like that is fine. And yeah, anything that helps you determine the endpoint is fine. Ethane dioic acid is solid. Calculate the mass to make a 250 cm cube of a solution of that concentration. So 250 cm cubed equals to 0.25 dm cubed. Oops, that's not a cube, that's C. 10.25 of dm cube is that volume, so I need a concentration of 0.048, and I have the volume, which gives me the number of moles. So I have 0.012 mole, and with the mole and the MR of 90, we can find out the mass equals to 1.08 grams, and that would be the answer. The student found that 25 ml of the sodium hydroxide was neutralized by 15 ml of that concentration. Calculate the concentration of sodium hydroxide in that concentration. Right, okay. So we know we want to find how many mole of that we've used initially, which is 15 cm cubed of 0.048 mole per dm cubed, and I know that 15 cm cubed is 0.015 dm cubed, and that times the concentration gives me the mole. Let's see, 0.015 times 0.048 gives me 7.2 times 10 to the minus 4. And we know that for the diacid to sodium hydroxide is 2:1 ratio, which means that the mole of sodium hydroxide, not sure why I wrote the actual name for it, but okay, is 2 times 7.2 times 10 to the minus 4, which gives me 1.44 times 10 to the minus 3 moles, and I have 25 cm cubed, which is 0.025 dm cubed, and you want to divide that mole per decimeter cube for the units, which is 0.0576 moles per decimeter cube, exactly 3 significant figures. Right, so that's it. That's the end of the paper, and hope you've learned something. And I did spend slightly over time of the 1 hour 30, but I was explaining a lot of things on the side as well, so I hope you've learned something and hope this paper seemed to be straightforward to you. I think the main issue is for people would probably be not realizing this question is aqueous, so probably did something like ammonia and potassium on this and that answer. Some of these long questions, these paragraph type questions, are mostly tricky, and I suppose the question on bond strength, calculating bond enthalpies, these ones are typically really stressful for people, because you need to remember the definition of bond energy, and it just confuses people. People add the delta H on the wrong side of the equation a lot of the times. I was a serial offender of that back in the days when I was young. But things like that, yeah. But aside from that, the paper seems reasonable. It's not easy, but it's not too difficult either. Most of these math questions work alright. This question is a bit silly, but it is correct. And yeah, overall, a decent paper. You should probably be able to do it without too much trouble. And yeah, hope you've learned something and you've enjoyed the walkthrough. And if you have any other questions, do let me know in the comments below. But without more to say, I will see you next time.